So hi friends, let's come to the next part of assignment. In this we'll be solving problem number 3. A has one surplus truck in each cities A, B, C, D and E and one deficit truck in each of the cities 1, 2, 3, 4, 5 and 6. The distance between the cities in kilometers is shown in the matrix below. So what is a matrix, Nana? Kilometers. So when it's kilometers, obviously will it be a minimization one or a maximization one? Definitely it's going to be minimization because kilometers will eventually convert into cost. So we would like to reduce the cost or increase the cost, obviously reduce the cost, and therefore it will be a minimization problem, right? And look at the question over here. You have 6 columns and you've got 1, 2, 3, 4, 5, 5 rows. Okay, let's see what is asked. So it is unbalanced. Find the assignment of trucks from the cities in surplus to cities in deficit so that the total distance covered by the vehicles is minimum. So it is very clear in the question. He wants the total distance to be covered by the vehicles is minimum, which means it is a minimization problem. Okay, now you just read this question. We'll start solving. Right, Anna. So let's look at third problem. Okay, now the order of the matrix is the order of the matrix is 5 by 6, correct? 5 rows and 6 columns. So it is what, Nana? Unbalanced assignment problem. It is unbalanced assignment problem. So what we need to do? We need to balance it before solving. We need to balance it before solving. So now the question is how to balance it? Pretty simple. You need to add a dummy row. You need to add a dummy row for the deficient number. For the deficient number, all the elements of the dummy row will be 0. All the elements of the dummy row will be what, Nana? 0. So that's very important. All the elements of the dummy row will be 0. So which means how the matrix will look like? Let's see here. 12, 10, 15, 22, 18, 8. Then you have 10, 8, 25, 15, 16, 12. Then we have 11, 10, 3, 8, 5, 9. Then you have 6, 4, 10, 13, 13, 12. Then I have 8, 12, 11, 7, 3, 10. Then you have 0, 0, 0, 0, 0, 0. So this is your matrix. Now tell me, is it balanced now? Yes, it is balanced. Okay, is it minimization matrix? Yes, it is minimization matrix, which means all the two conditions are satisfied. Can I solve this problem now? Answer is yes. You got the point? So what we have done is we have converted an unbalanced problem into a balanced one by adding a dummy row. Is that clear? By adding a dummy row. So once the dummy row is added, now that it has become what? Balanced. So it is balanced and it is a minimization problem, obviously. So straight away we can go for the regular steps. So what is the first step, Nana? The first step will be row operation. The first step will be row operation. So row operation means we already know. Take the least element from each row and reduce it from the rest. Look at the next step here. We'll do it for the first row. Remaining rows, I'll directly put the answer. Okay. So what is the least number, Nana, here? The least number is 8. Correct? You reduce it from the entire row, which means 12 minus 8, it's gonna be 4. 10 minus 8, 2. 15 minus 8, it's gonna be 7. 22 minus 8, it's gonna be 14. 18 minus 8, it's going to be 10, and 8 minus 8, it's going to be 0. So same thing we have to do for second row, third row, fourth row, fifth row, and sixth row. Correct? In each and every row, select the least element and then reduce the entire row from that particular number. Right, Nana? So let's do the row operation. So what's going to be our matrix after row operation is what we are going to see. So it will be 4, 2, 7, 14, 10, 0. Then for the second row, it's going to be 0, 8, 15, 5, 6, 2. Third row, 8, 7, 0, 5, 2, 6. Fourth row, 0, 8, 4, 7, 7, 6. Fifth, 5, 9, 8, 4, 0, 7. And last, 0, 0, 0, 0, 0, 0. Because if it is entirely 0, the least is 0. 0 minus 0 will give you 0 only, right? So it remains the same. Got it? Now, guys who are watching the video, please understand you have to do along with me simultaneously. You got to do along with me simultaneously. You take your pen, you take your paper, you take your book, and then do along with me simultaneously while watching the video. Don't just watch the video without doing. It's not gonna work. When it comes to OR, operations research, it's all about practice. So you do along with me simultaneously. Is that clear? Right. Now, what is the next step? Next step will be column operation. Now, no need to do any column operation. Why there is no need? Why? Because in each and every column you have a 0, correct? As a result, what will happen? What is column operation? Select the least element from a column. So what is the least element in the first column? 0. And reduce it from the rest. So 4 minus 0, 0 minus 0, 8 minus 0, 0 minus 0, 5 minus 0, 0 minus 0. You'll get the same column. Same logic applies to the second column as well. What is the least number in that second column? 0 again, right? And you have to reduce it from the rest. So what will happen? 2 minus 0, 8 minus 0, 7 minus 0, 8 minus 0, 9 minus 0, 0 minus 0. You'll get the same. Third column same, fourth column same, fifth column same, sixth column same, which means we'll get the same matrix again. So after column operation, we haven't done anything special. We're going to get the same matrix. So 4, 2, 17, 14, 10, 0, 0, 8, 15, 5, 6, 2. We need to put these steps, okay, because we need to get marks in the exam. So 8, 7, 0, 5, 2, 6, 0, 8, 4, 7, 7, 6. Then we have 5, 9, 8, 4, 0, 7. Then we have 0, 0, 0, 0, 0, 0. Done. Okay, after column operation, what is the next step we need to do? Covering zeros with minimum number of lines. Let's do that. Let's do that. Okay, covering zeros with minimum number of lines. Now, let's look at the first row. So what did I say? What was the logic I told you? To cover zeros with minimum number of lines, select that row or that column which has got maximum number of zeros. Select that row or that column which has got maximum number of zeros. Select that row or that column which has got maximum number of zeros. It's very easy. Which is the row which has got maximum number of zeros? Last row, obviously, because it's a dummy. Now check the remaining. First row 1 0. Okay. Second row 1 0. Third row 1 0. Fourth row 1 0. Fifth row 1 0. So all the rows are having 1 0. Columns. First column 2 zeros. Second column nothing. Third column 1. Fourth column nothing. Fifth column 1. Sixth column 1. So I'll go with first column. Why? Because I've got 2 zeros. Correct? Now we have how many? You got 1 0 here, 1 0 here, 1 0 here. If you go column wise, this column will be one line, this column another line, this column another line. Correct? This 0 gets covered, this 0 gets covered, and then this 0 gets covered, right? So therefore 1 0, 2 0, 3 0. So you'll be getting 3 columns, 3 lines. Or even if you go with rows also, here 1 0 will be covered, one line, second 0 will be covered, another line, third 0 will be covered, another line. You got the point? So I'll go row wise. There is no rule that you need to go like this row wise. You can go column wise also like this. 1, 2, 3. Like that also you can go. 1, 2, 3. Like that also you can go. Is that clear? I went row wise. It doesn't matter. Is that clear? See, maybe one iteration will increase or one iteration will decrease, but ultimately your answer is going to be the same. You can choose either rows or columns. There is no strict rules over here. Is that clear? Right. Chalo. Now Routine check. What is that? Is number of lines is equal to order of the matrix. Is number of lines is equal to order of the matrix? Answer, no. Which means we cannot proceed for assignment directly, which means we need to proceed for iteration. Iteration can also be called as improvement. What do you mean by improvement? It means that whatever the solution that you have got right now is not the best solution. It means that whatever the solution that you have got right now is not the best solution, and there is a better, even better solution which is waiting. You got the point? Therefore, what we are going to do is that we're going to do improvement for this existing solution. We're going to do improvement for this existing solution, and then again we're going to see whether we are going to get a better answer or not. That is the whole logic here. So the rule is, if number of lines is equal to order of the matrix, then directly we'll proceed for assignment, because that rule proves that this is the best answer what we have got. In case if number of lines is not equal to order of the matrix, then it means that whatever whatever the initial whatever the initial answer that you have got right now, which you can see it on the screen, is not the best answer. There is even better answer which can be possible, and therefore we're gonna go for iteration or improvement. Is that clear? Now, what are the rules for iteration or improvement? Very simple. See, now listen carefully, listen carefully, listen carefully. Okay, now look at all the numbers here. You can find certain numbers, these numbers 8, 15, 5, 6, 2, all these are uncovered numbers. They are not covered with lines, correct? All these numbers. Whereas look at the remaining numbers, they are covered with lines. So I call it as covered numbers. All these rounded up for uncovered. So they are uncovered. These are all covered. Now in covered, can you see the intersection points here? This we call it as junction. What do we call them? Junction. All the intersection points, we call it as what, Nana? Junction, 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 junction. You got the point? Now keep these 3 points in your mind. One is uncovered, the other one is covered. All these numbers covered with lines, we call it as covered. And the third one is junction. Junction means you have intersection. 4 is a junction, 8 is a junction, 5 is a junction, 0 is a junction. Junction, 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 junction. You got the point? Chalo. Let me change the ink color to make it better. Right, guys. Okay. So this is a junction, junction, junction. This is also a junction. Now, what we need to do? Pretty simple. You have to select least uncovered number. Okay, this red looks very bad. Does blue suit? Yes. We need to select what, Nana? Least uncovered number. Least. These are all uncovered numbers, right? 8, 15, 5, 6, 2, 8, 4, 7, 7, 6. What is the least uncovered number? 2. Correct? Take least uncovered number and you reduce it from all the uncovered numbers. Okay, let me write the steps here. First one, select least uncovered number. Okay, in our answer it is 2. Next, reduce it from all uncovered numbers. Reduce it from all uncovered numbers. Third, add it to the junctions. Where we need to add it, Anna? To the junctions. Then you can ask me, what about covered and the non-junction numbers? What about the numbers which are covered and they are not in junctions? You leave them as it is. Leave them as it is. Leave them as it is. You got the point? These are all the 4 steps. These are all the 4 steps of improvement. Okay, these are all the 4 steps of improvement. Now again, let me recall the steps. What are the steps now that we have got? First one, select the least uncovered number, which is 2 in our case. Reduce that number from all the uncovered numbers. Add it to the junction. Wherever you find junction numbers, you add. Covered and non-junction numbers, you leave them as it is. So you add it. Whereas from uncovered numbers, you reduce it. Junction means you add it. Remaining covered and non-junction, you leave them as it is. So no change. So now come back here. So what you're going to do here, 2 is the least uncovered number. So here it's going to be 8 minus 2, 15 minus 2, 5 minus 2, 6 minus 2, 2 minus 2. You got the point? So that's what you're going to do, right? Next, 8 minus 2, 4 minus 2, 7 minus 2, 7 minus 2, 6 minus 2. Got it? Then here you need to add 2. 4 plus 2, 8 plus 2, 5 plus 2, 0 plus 2. Remaining numbers, you leave them as it is, the covered and non-junction. Okay, if you do this working, you'll get the resultant matrix like this. After first improvement. Okay, this is the resultant matrix, Nana, after first improvement. So 6, 2, 7, 14, 10, 0, 0, 6, 13, 3, 4, 0, 10, 7, 0, 5, 2, 6, 0, 6, 2, 5, 5, 4, 7, 9, 8, 4, 0, 7, 2, 0, 0, 0, 0, 0. Is that clear? This is going to be a new matrix. Okay, now this is my new solution after improvement. This is my new solution. Again, I need to check whether this is the best solution or not. Again, I need to check whether this is the best solution or not. So what will I do? Again, I'll cover zeros, covering zeros with minimum number of lines. Again, covering zeros with minimum number of lines. Okay. So actually what you have to do, you need to repeat this matrix again. Here you need to repeat this matrix again. You repeat this entire matrix again, and then again you need to cover it with zeros. I mean, cover it with minimum number of lines. I'll do it here itself. Okay. When you're writing in the exam, you have to repeat this step again. I'll do it here itself. Now see here. Obviously, you have the last row, which has got 1, 2, 3, 4, 5, 5 zeros. So I'll go with the last row first. I'll go with the last row, because what is the rule I told you? To cover zeros with minimum number of lines, select that row or that column which has got maximum number of zeros, correct? So I got the last one. Then coming on to here, I've got 1 0, 2 zeros. Let me write 1, 2, 1, 1, 1. Okay, coming on to columns, 2, nothing here, 1, nothing, 1, 1. Okay, same logic. Okay, I'll go with the column now because it has got 2 zeros. I can go with second row also. Is that clear? That's your wish, right? Now what I can do, sorry, I have 2 zeros in the last column as well. Okay, I'll go with last column which has got 2 zeros. See, you have one row with 2 zeros, whereas you have two columns with 2 zeros. Therefore, I went for columns. Is that clear? So first column and last column has got 2 zeros, whereas if you check the rows, there was only one row which has got 2 zeros. Is that clear? So I went with first column and last column. Now you have 1 0 here. Okay, you have 1 0 here left over, you have 1 0 here. You can again go with two columns, or you can go with rows. So I'll go with rows like this, 1, 2. Is that clear? I've covered all the zeros now with minimum number of lines. Otherwise you can go like this also. From 7 you can put a column here to cover this 0. From 10 you can put a column here to cover this 0. Anyway, now tell me the rule now. Is number of lines is equal to order of the matrix. Is it? So what's your number of lines? 1, 2, 3, 4, 5. So 5 is equal to, what is the order of the matrix? You can see it has got 6 columns and 6 rows. Correct? So 6 into 6. Your answer is no. So again we need to proceed for what? Improvement. Again we need to proceed for what, Nana? Improvement. So this is very important. Got it? But this important point you remember, while drawing lines, we had a situation where one row has got 2 zeros. That is this one. Okay, and two columns had 2 zeros, that is this column and this column. Okay, since there were more columns with maximum zeros, we opted to draw the lines against the columns. Is that clear? This is very important, right? Chalo. Now we need to apply the same rule. So what is the same rule? Now we need to go for iteration. Why? Because this rule is not satisfied, which means again what? Select the least uncovered number. Again 2 is the least uncovered number. Okay. You reduce it from all the uncovered numbers. So 2 minus 2, 7 minus 2, 14 minus 2, 10 minus 2, 6 minus 2, 13 minus 2, 3 minus 2, 4 minus 2, 6 minus 2, 2 minus 2, 5 minus 2, 5 minus 2. Okay. Junctions. 10 is a junction plus 2, 7 is a junction plus 2, 2 is a junction plus 2, 0 is a junction plus 2, 7 is a junction plus 2, 6 is a junction plus 2. Remaining, you leave them as it is. So let's look at the improved solution after second iteration, or you can also call it as second improvement. So after second improvement, what's gonna be your answer? Is it clear? Look at the previous one. This is the before second improvement, right? This is after first improvement. Now I've already put there. So you do those calculation, you'll get the second one. Is that clear? Yes. Chalo. Let's look at the answer. 6, 0, 5, 12, 8, 0, 0, 4, 11, 1, 2, 0. You have to look your notes and then you put this one, because in your notes you have already calculated na. So in your notes this is visible, below this only you'll be doing it. So do along with me simultaneously. What is the next one? 12, 7, 0, 5, 2, 8, 0, 4, 0, 3, 3, 4, 9, 9, 8, 4, 0, 9, 4, 0, 0, 0, 0, 2. So I also have a notes with me and I'm trying to solve it. Is that clear? So you also do along with me simultaneously. Now, again, we have to do the same thing. So this is a new solution again. This is new solution. Now, again, I need to check whether this is the best solution or not. So what I have to do, again, cover zeros with minimum number of lines. Is that clear? So again, check it. So how can you cover it with minimum number of lines? Let's see. Here you've got rows. First row, 2 zeros. Second row, 2 zeros. Third row, 1 zero. Fourth row, 2 zeros. Fifth row, 1 zero. Sixth row, 4 zeros. Columns, first column, 2 zeros. Second column, 2 zeros. Third column, 3 zeros. Fourth column, 1. Fifth column, 2 zeros. Sixth column, 2 zeros. Okay, first I'll go with the last row where you have got 4 zeros. Okay, so 4 is gone. What is the next highest number? 3. So now it is not 3. Why? Because now once 4 is gone, you have got only 2 here. Correct? Here also you have only 1. Here you have 2. Here even that 1 is not there. Here also there is only 1. Here there's 2. You got it? So now you have 3 rows with 2, whereas you have got 1, 2, 3 columns with 2. Can you see here? 2, 2, 2. Rows you see 2, 2, 2. So I can go with rows or columns. It's my wish. I can go with rows or columns. Is that clear, Nana? So what I can do is, can I go with the first row? Yes, 2 zeros. Can I go with the second row? Yes, 2 zeros. Can I go with this row? Yes, 2 zeros. Is that clear? Now only 2 zeros are left. Already I went with rows, so I'll go with rows as well, right? So therefore, number of lines 6 is equal to order of the matrix 6. So can I proceed for assignment? Yes. So proceed for assignment. So proceed for assignment. You got the point? Chalo. Now let's repeat the same matrix. 6, 0, 5, 12, 8, 0, 0, 4, 11, 1, 2, 0, 12, 7, 0, 5, 2, 8, 0, 4, 0, 5, 2, 8, 9, 9, 8, 4, 0, 9, 4, 0, 0, 0, 0, 2. Okay, what is this step, Nana? Assignment. So assignment, I already told you. What is the rule? Select that row or that column which has got single zero. So first row, 2 zeros. 2 zeros. No. Second row, 2 zeros. Third row, 1 zero. So assign. This gets cancelled, this gets cancelled, because in that respective column there is another zero. Correct? Fourth row there is only 1 0. So assign. Then immediately this gets cancelled. Correct? Fourth row, I've assigned one single zero. Then immediately in that respective column, this zero gets cancelled. Immediately you see in this row, only one zero is there, correct? In this second row, assign this. Immediately in this respective column, another zero gets cancelled. Now immediately in this row, there is only one zero, correct? Now you assign this. Immediately in this column, this zero gets cancelled. Okay. Now can I assign in the last row? No, because there are two zeros. Last before row, how many zeros are there? One zero. So I can assign this. Then this gets cancelled. Then finally only one zero is left in the last row. This is also assigned. So 1, 2, 3, 4, 5, 6. Everything is assigned. I'll repeat it one more time. Okay. I'll repeat it one more time. I'll explain you. 6, 0, 5, 12, 8, 0, 0, 4, 11, 1, 2, 0, 12, 7, 0, 5, 2, 8, 0, 4, 0, 3, 3, 4, 9, 9, 8, 4, 0, 9, 4, 0, 0, 0, 0, 2. Okay. So first row, two zeros, I cannot assign. Second row, two zeros, I cannot assign. Third row, single zero I can assign. Respective column, zeros gets cancelled. Now once it has got cancelled in the next row, in the fourth row, now I have got only one zero. So assign this, and in this respective column, another zero gets cancelled. Now in this row itself, now it has got only one zero. So I will assign this. In this respective column, this zero gets cancelled. Now in this respective row, there is only one zero. So assign it. Now in this particular column, there is one more zero which gets cancelled. Now in this respective row, there are two zeros, correct? I cannot assign. So go to the previous row. There is only one zero. Can I assign this? Yes. Now this zero gets cancelled because it is in the respective column. And this is the only zero that is left over. So you assign. Answer is done. So therefore, what will be your final answer? This is you have your columns and then you have your rows. So this is A, B, C, D, E, F, and this will be 1, 2, 3, 4, 5, 6. So what is your final solution? Final solution. Cities, cities. So A city has got 2, correct? So A has got 2. B, B has got 6. Okay. C has got 3. Okay. D has got 1. D has got 1. E has got 5. E has got 5. I don't have space here. Then F has got 4. Okay. Distance in kilometers. A to 2. Look at the original matrix, right? 10. B to 6. 12. Look at the original matrix. C to 3. 3. D to 1. 6. E to 5. E to 5 is 3. F to 4 is dummy. So therefore it is 0. So the final answer will be 34. So 5 cities have truck and 6 cities requires truck. This means there will be one city going without truck. As per the assignment, it is the last city, that is city F, which is a dummy because fifth row is a dummy. So city F does not exist, whereas city 4 does exist. So this is real. City 4 is real and this is a dummy. So this dummy F is allocated to city 4, which means city 4 is the one which goes without truck. That is the logic over here. Is that clear? Because F is a dummy and for F city 4 is assigned. Therefore F does not exist. Therefore city 4 is the one which goes without truck. And this is your final answer. Is that clear, Nana? So I hope you have understood this particular problem. No ways. If at all anything is there, you can watch the video again. Despite that, if you got any problem, you can WhatsApp me. Right, guys? Thank you so much. We'll wind up this particular session. Thank you.